Hello and welcome to our chapter on graphs. So, what we're going to do this chapter is we are going to explore graphs. Graphs are data structures which are suited for showing the relationships between different things. And that's an extremely abstract power that these have. These are extremely powerful data structures and they're extremely versatile, and as a result they have been studied for a long time. They've been studied much longer than computer science has been a thing. So we're going to learn about graph vocabulary like edges and vertices. We're going to learn about different types of graphs. So directed graphs, weighted graphs, directed acyclic graphs. We're going to focus our discussion on simple graphs, which we'll define later. Next, we're going to study different ways we can implement a graph abstract data type. Different ways we can implement graphs: adjacency list versus adjacency matrix. And rather than writing that up on our own, we're going to use a jar file or an external library. So we're going to see how we can use an external library to do that rather than coding it up on our own, which is a very valuable skill. So next step after that is that once we learn what graphs are and now that we can use them, we are going to learn the algorithms, the common algorithms, breadth first search, depth first search. Then we're going to move on to algorithms that involve weighted graphs, specifically Dijkstra's algorithms. Do you ever encounter graphs in a class? You're going to be learning Dijkstra's algorithms. It's a given. It doesn't matter if you're in a senior level class or a sophomore level class. You're going to be learning Dijkstra's algorithm. It's just always happens. And then finally, we are going to study different ways we can use some more ways we can use graphs, such as topological sort. So graphs, again, here they're talking about that graphs are kind of generalized tree. You can have more than one parent, but that's really kind of just giving you the wrong impression of graphs. Graphs define relationships. So, for instance, let's go ahead and briefly just kind of show you graphs. But why are graphs important? They make the internet work. They determine placement of components. They show how you can run large communication networks. But they solve problems like which route should I take, which courses you need to take before you can take the next course, what is the shortest path, what is the cheapest thing I can do. Those kind of questions are solved by graphs. So next video, I'm going to just basically explain kind of what do we mean when a graph talks about relationships.